Okay, so in the previous pages, we have shown that we can use this iterator model to execute the queries for all the nodes inside the logic tree, right? So for processing the queries. And we will show you the example to do the scanning of the tables for the initial operation of the tables in the logic tree we showed before, right? For the scanning of the table, this operation we have to define its open, its next, and its close, its functions for it. Then the next question will be, because we have a logic tree, right? We can define this function for each node inside the logic tree. However, we have tree structure. How can we organize these kinds of operations among all the nodes inside the tree? In other words, for this iterator model, it have to have a plan for the execution of the operation for all the nodes inside the tree, right? And this page will show you how this algorithm or this model will dealing with this kind of problem. For iterator model, the query execution, we always begin with the root iterator, right? It is easy to understand because we have a root there. And for all the parent nodes, it will have some children nodes inside the tree structure, right? So for all the parent nodes, we will define its open, its next, its close, its functions. It is just very similar to the one we showed before, right? Because every node inside the tree will define its three functions. And because it is a tree structure, and for the parent node, this open function will actually invokes this child open function. And sometimes it will also invoke this child next function. In other words, we also do the child opens, and sometimes we also do the child next. And for the parent next function, it will also involve child next as well. In other words, once we call the next for parent, inside it we also call the next for child. And it will be similar here. If we do the close for the parent node, we also invoke the child close as well. Just as shown here, when we define open, next, and close functions for the parent nodes, inside we have to call child open, child next, child close, prior or do some other operations or some steps inside functions. So what does this mean? Given a tree we showed in the previous page, once we plan to do the operation for the projection buyer, and we do the open first, open this operation. However, in this open function, we have to invoke its child open, and we further invoke its child open, and further invoke its child open, right? In other words, prior to do any open operation or steps for the projection step, we will do the open for all the nodes until the different nodes, right? It will be similar for the next. If we do the next for the projection of buyer, it will also invoke this next to this node, as well as the diff nodes, right? So for all the operations we do for the root node, it will invoke this kinds of operation for the different nodes prior to do anything, for the nodes. Because this open, next, close, they are all before the following operation and steps as shown in the algorithms, right? So this is the iterator model we can use for executing and as well define the query processing steps in database systems. So for executing the queries, we actually have two different mechanisms. The first one is called materialization, and the second one is called pipeline. There are two different ways to executing the queries. For the materialization, inside kind of mechanism, the result of each operation is stored on the disk until it is needed by other operations. This kind of mechanism is easy to follow, right? In other words, in this kind of mechanism, we have to store all the results into a disk. It may require very high disk I/O, right? And also we can do one single operation at one time. It is very easy to do, also easy to implement. However, it has some shortcomings. Another way we do the execution of queries is via the pipelines. In other words, the result of each operation is created in the main memory and passed directly to the operations that use it. In this way, it can save not so disk I/O because we don't need to store the results to the disk, and the operations are performed simultaneously. However, we also have some challenges because it may fail when the size of the result as well as intermediate result structures exceed the limits of the memory. So in other words, once we do a pipeline for executing queries in database system, we have to ensure we have enough memory for fitting the results we create during the query processing time. Okay, so this is the query execution process inside database system for handling query inputs based on the logic tree we created before.